All right. Well, hopefully you found that pretty interesting. And what I found really interesting about it is the idea that they were doing something else and it was accidentally as they were moving the slide through. And the cat's eye could see that, could detect that slide edge moving through, that they discovered, hold on, we've got these feature detectors that are firing. So kind of an interesting accident, serendipity. All right. So analysis by synthesis is proposed to be a three-step process. So first off, you have to extract the information from the sensory register as a set of individual features that are making up the object or the pattern. Then you have to identify the features by matching them to the different, to the feature list, right? The feature templates, which is going to be shorter than if you had to search through every template, like I mentioned before. And then ultimately you synthesize. The pattern with the most overlapping features is going to be selected as the pattern that is probably represented out in the world. In order to do that, you sort of have to recombine the features that you've collected and see if what you have collected through your sensory organ is matching the pattern that you have selected from your memory, right? That you have the most overlapping features. Is this really the same thing? So there's like these multiple levels of steps that have to go on in order for you to actually recognize something. I'm going to harken back to something I said earlier about how much our brain doesn't like it when we can't recognize something, and it really makes us kind of struggle. Like, what is that? I almost can recognize that tune, but I can't figure out what it is. Or what does that smell? It smells kind of familiar. It reminds me of something, right? You've had those experiences. Sometimes what we might be struggling with in those circumstances, according to this theory, is it's matching some features that we have stored, but not enough for us to say, I can pull out a recollection of what exactly that is. Like, it's not matching it enough. So this theory has that multiple stage process. Just like I said with the template theory, context is going to be key with the analysis by synthesis also, right? That, if you smell something that smells like cooking while you're sitting in a classroom and you're not at some kind of cooking, school, or you're not next to the cafeteria, you're going to maybe have different interpretations of what those odors are and what they might mean than if you're at home and it's getting to be supper time and you know that somebody's making dinner, and right, like, context is going to really help you to figure out what these features really are representing. So distance context can determine the size of an after image. Okay, this is actually really an interesting phenomenon where if you stare at the dot in the center of this flag, it'll sit here and I'll talk while you're staring at the dot in the center of this flag. So if you look at this while it's on the screen and you see what size it is on your screen and so on, your brain is like, okay, well, that's how big that object is when looking at it on whatever device you're looking at, right? So you're sort of looking at the screen. It's looking however big it's looking to you. I'm on my laptop. Mine's looking, yep. And then now, if you continue to look at that device, you'll see the after image in the red, white, and blue. Now look somewhere else. Look at a distance. Look up close. Look around, and you'll see that that flag is changing size as you look around. So if you look off into the distance, the flag will look bigger. If you look at something closer up, the flag will look smaller. It's accommodating for the distance of the object that it's being cast on. That's kind of a sign that that your brain is trying to make sense of. It's taking the different features and it's putting it together to try and make it fit what it thinks is going on, what this pattern really is. So once it recognized that it was the flag, it was like, okay, well, when I'm looking at the screen, the flag is being cast onto this laptop screen and it's appearing this size. Then when I look up and look at a wall, it goes, okay, well, now it's being cast on the wall and now it needs to be this size to accommodate the distance. It just sort of, it grows with it. And that's another piece of evidence that maybe your brain is synthesizing the different features and putting context, distance context, the object, all those things together and making it make sense. The context of your expectations plays a huge role. I mentioned expectations as one of those factors that helps us to do pattern recognition in general. But if you expect something, you tend to see that thing. So in an experiment, they showed group A this picture that you're seeing right now. The group B saw the image on the right first. So on the left, it's clearly got details that make it pretty clear that it's a man playing sorry, I was never in band. I think that's a saxophone. And then the picture on the right is clearly a woman. Now when they're shown this ambiguous figure in the middle, group A tends to see it as a sax player and the group B sees it as a woman. Hope that's a saxophone because that's what I labeled it. Your expectation makes it super obvious what that ambiguous figure is, right? Well, I saw the saxophone player, so now it's still a saxophone player. Yeah, you took some of the details off of it, but it's still a saxophone player. If you saw the woman first, you say, well, it's obviously a woman. You don't even necessarily notice the aspects that would make it look like a saxophone player. So the expectations that a person carries into an environment helps them to synthesize those features much more quickly. Helps them to search through the templates, the feature list much more quickly because they just saw that other less ambiguous picture. So it's a lot easier for them. So very quickly they see the object as what they had previously been shown before. So expectations play a huge role, and then social perceptions play a huge role as a context cue. What is deemed a house that you would want may be affected by what you've been exposed to, right? What has been judged as attractive or valuable can help you to make determinations. When I was a kid, I was raised watching Charlie's Angels. And so imagine, you may not have any clue what you're looking at, but I think you can imagine what kind of impact watching these three women, running and chasing bad guys supposedly and things like that might have had, what kind of impact that might have had on, the role of women and the role of appearance and other kinds of social perceptions, on a budding, young girl's mind, right? Like these things have an impact on how we interpret information and form patterns and all those kinds of things. So it's really important to think about context whenever you're thinking about pattern recognition. All right. Now this is kind of disappointing because we're online instead of face-to-face. And so you can't get with a group and work on this. Maybe I will make this a little discussion. Yeah, no, see, it's kind of hard. It's really hard. So I'll just tell you what the premise is. So half of the class is asked to work on this problem where you have a night race. It was a dark and misty night as Sandy ran across campus. A streetlight cast the shadow of another person close behind. With heart pounding, Sandy accelerated away from the pursuer and headed for the dorm. The other half of the class works on this one, laundry. It was a dark and stormy night. Chris was alone in the apartment laundry room. The lights flickered and there was the shadow of a person in the doorway. Both groups are asked to generate an ending to the story, describe who the person is, who is the lead character, Sandy on the left, Chris on the right, who the shadowy figure is, right? You've got another person close behind on the left, and you've got the shadowy person in the doorway on the right. Like, who is that? What's happening? What's going on? Like, tell a story. And a lot of times what you find is that if Sandy is perceived as female or Chris is perceived as female, a lot of times the story takes a bad guy's going to get you kind of turn. If Sandy or Chris is interpreted as male, it's much more likely that the groups come up with either something funny, where it was just a misunderstanding, or something heroic, where Sandy and or Chris are able to vanquish whatever the scary thing was. So it's kind of an interesting example of how our preconceived notions will drive very ambiguous information. I mean, I think we can agree that the name Sandy and the name Chris, those can be male or female names. There's nothing in either of these stories that give you any impression of what's going on at all. And so for us to sort of project something scary if it's a female actor and something heroic or vanquishing if it's a male character, it kind of implies that we take these kinds of contexts into account. And it's easy for all of us to sit here and go, well, if I was in the group, I wouldn't generate that. But I've been doing this demonstration for like 20 years, and it's what always happens. Like 100% of the time, I've never had groups not come up with something scary if they perceive the actor to be female, and something funny or vanquishing if it was male. So it's just something that maybe it's a function of group work. You know how sometimes we think about things differently if we're with a group. So anyway, it's a little demonstration that shows social perception. All right, so the basic tasks of visual perception. Pre-attentive processing is when we organize the stimuli into the discrete elements that we're going to be processing, and then post-attentive processing is the identification of the elements for further processing. So pre-attentive is the organization, post-attentive is the identification part. So, luckily, there are some rules that our brain seems to follow when organizing the objects of our perception. So information has come in through our sensory organs, and now our brain is going to try and make sense of what came in, right? We've got pattern recognition. We have organizational rules for trying to figure out what elements make up the pattern. So, grouping principles. We tend to group similar items together. So you probably see this as a series of squares and forming a plus sign, and circles making little squares within that plus sign, right? You don't see this as just a series of random objects. You're seeing a pattern, a plus sign, and then circles within it. Proximity. You probably are seeing this as 3 stripes made up of dots, as opposed to 6 columns of circles. Like, the fact that some of them are closer together makes them seem like they're part of the same object. So you tend to see 3 stripes rather than 6 columns. Good continuation refers to the fact that even though there are gaps between these dots, you see them forming an X. Even though your brain just goes ahead and fills in those details in a process called good continuation. It's called good continuation because your brain tends to form objects that make sense. Like, you're just using the shape. You're not doing a lot of extra filling in. You're just filling in some gaps. Closure, you might be doing a little bit more filling in. Here, you are probably detecting or perceiving a white triangle on 3 black circles. Even though what's really there is 3 black circles with a little pie shape taken out of each of them, and then they're organized in such a way that those pie shapes are lined up to kind of make the corners of a triangle. Your brain is filling in the gap between the black circles so powerfully that you might even believe that you're seeing a line there. Like that, I've had students say, no, that white triangle is a different color of white than the white background that's behind the black circles. Like, it feels like that, doesn't it? And but it's not. It's a white background altogether. And then it's got those 3 circles that have the pie shape cut out of them, and your brain is closing the gaps that are between the black circles so that it looks like a white triangle. I don't know if you can see I think you can see my mouse when I'm moving it. I'm moving my mouse right now. Like, I honestly feel like there's a gray line between that white triangle and that background, but there's not. It's just white. Element connectedness. So, because the squares are joined to the triangle, to the circles with a dashed line, and not even perfectly connected, right? There's a little bit of space, but because they appear to be connected, we see that as, a square and a circle, like that's one figure. Instead of the similarity that might have overridden it, if those lines hadn't been there, we probably would have seen that as 2 squares and 2 circles and grouped them on shape similarity. But because there are lines connecting them, we now see it as two forms made up of a square and a circle each. Finally, I'm using the same picture as I did for proximity to refer to common region. The dots that are forming one stripe are dwelling within a common region. So you see the stripe on the left, the stripe in the center, and the stripe on the right. So we see the circles that are in the stripe on the left as being together. They are forming one pattern. The ones in the middle are forming another pattern, and the ones on the right are forming another pattern, right? That's called common region. There's been some great examples of common region thinking going on since coronavirus, where we act like it's, like a virus wouldn't pass across state lines or county lines or country borders. Washington has X number of cases and Idaho has Y number of cases. Like that matters. People drive across that border all the time. They fly across that border all the time. But when we think about states, we almost think about them being unique entities, like they're separate. And we see this when people talk about weather too, as if weather doesn't spread across a border. But we think about, Washington is its own little common region. Oregon is its own little common region, and we don't think about the fact that these are arbitrary markers that really have nothing to do with it, because our brains look for patterns. Our brain wants to organize things. And so Washington is its own little thing, and it's separate and different from the states that are abutting it, or the country that's abutting it on the top. Now look at the common region that formed when I drew the circles. Well, I guess those are ovals around those circles. Now that I put a circle around those two that had occupied different stripes, suddenly those seem like they belong to the same object, don't they? So I've made two new objects by putting those ovals in there, didn't I? It's amazing how just putting a border around something suddenly makes it seem like those objects within that border are now somehow together, right? They're part of the same pattern. All right. That's enough on grouping principles. Let's go ahead and take a break here, and we will come back in the next segment. We'll start with figure ground discrimination.